The topic for today is multiplying probabilities. One of the things that we need to talk about is the idea of we have actually two events happening, and we have two types of events that could be happening. One is independent, where one event has no effect on the other, and dependent, where the one event has a direct effect on the other. We'll get some examples in a minute. Typically, since there are two events, the operative word is going to be and tells us that we're going to have a multiplication of the two probabilities. All right. Once we get to dependent events, it gets a little trickier, but we'll talk about those in a moment. So in this case, cards drawn from a standard deck of 52 cards. There's a spinner, 4 equal sections of different color. What's the probability of drawing a jack and the spinner landing on a red? So we do these probabilities independent of each other. In a deck there's 4 jacks, so its probability is 4 out of 52, which is 1 over 13. And since it's an and, we're going to multiply that by getting a red, and there's 4 equally likely, so that's 1 over 4. And we'll multiply those together, so I get an answer of 1/52. This is independent because of the fact that no matter what card I draw, it doesn't affect the spin. We move to this, we get 3 people are picked to draw prizes, and there are 4 pairs of sunglasses, 5 keychains, and 6 tickets for a baseball game that are available to draw. And we want to know the probability that the first person gets the sunglasses, second person gets a ticket, and the third person gets a keychain. So, and they're going to draw in that order. So in this case, the order is important. That doesn't necessarily give us a permutation, but knowing the fact that order matters is important. So the first person, we want to find the probability of drawing a pair of sunglasses. Well, there's 4 sunglasses out of a total of 15 items. So 4 out of 15 is that person's probability. Now, the next person is going to draw a ticket. And there are 6 tickets, but in this case, there are only 14 ways to draw them. So that's 6 out of 14. And then finally, the person's going to draw a keychain. So there are 5 keychains available, but there are only 13 items left. So when we do this multiplication, we see we can do a little reduction. The 5 and the 15 go to a 3. The 4 and the 14 go to a 7. And then we're just multiplying these. And in so doing, we end up with 4 over 91 as our probability. This is dependent because when we draw one item, we reduce the number of total items I can pick from for the next item. So the probability is going to change. If we were to replace the item after we drew it, then that would be independent because I'd still have the same chances of drawing the next item. Alright, so let's do this problem, and note it's going to be a little bit different still. We have 12 blue marbles, 9 red marbles in a box. We want the probability of drawing 3 blue and 2 red. Note, we didn't talk about the order in which they draw these out, so order doesn't matter. In these types of problems where order doesn't matter, I typically go to a combination because I could draw 3 blue items a lot of different ways. I could go blue, red, blue, red, blue. I could go blue, blue, red, red, blue, etc., etc., etc. And that's going to change the total number of ways. So when order doesn't matter, I use combinations to do the problem. So I want to ensure that I get 3 blue. So in order to get 3 blue, I take from the blue only 12, choose 3. That gets me the number of blue marbles that I want. And to ensure my 2 reds, I take from the red only. So 9 choose 2. Since these are 2 separate events, I multiply them together, and then I divide by the total number of ways to choose 5 items, 3 and 2. So I have a total of 21 items, and I'm choosing 5. And then we can calculate that using the calculator, and we end up getting 880 over 2261, which if we wanted to, we could also represent as about 39%. So now we talk about conditional probability. Let's read through it first. A conditional probability of an event B happening in relation to event A is the probability that B is going to happen given that A has already happened. And the notation for that is probability of B, and this little straight line right here means given A has already happened. The actual calculation is the probability of A and B divided by the probability of A. So in this example, which is pretty straightforward, Susan takes 2 tests. The probability of her passing both, and that's the key word here, is 0.6 or 60%. The probability of her passing the first test is 80%, and we want the probability of her passing the second test given that she has passed the first test. So this is the probability of 2 given 1. All right, and we need to find the probability of passing both tests. Well, that's right here, 0.6, and the probability of her passing just the first test was 0.8. So this is as simple as 0.6 divided by 0.8, which gives me 75%, or 3 out of 4. So here's another example given without the actual probabilities. So we've got to figure these out. It says out of 50 people surveyed in the study, we've got 35 who smoke, in which 20 are males. What's the probability that if the person surveyed is a smoker, then he's a male? So if I were to write this out, this is P male given smoker. So we want the probability of the person being a male and a smoker. Well, it says right here there's 35 who smoke and 20 are males. So that's 20 out of a total of 50 people surveyed. And then we want the probability of a person being a smoker. 35 smoke out of the 50, so that's 35 over 50. And now we take and divide the 2. So we have 20 over 50 divided by 35 over 50, which is 20 over 35, or what is that? 5 goes into this 4 times and 7 times here. So our next example, this is also a form of conditional probability, but they use tables, and I think this is a little bit easier because you can reference this rather than having to think about it all on your own and organize it on your own. You got a public opinion survey explored the relationship between the age and support for increasing the minimum wage. In the 21 to 40 age group, what percentage supports increasing the minimum wage? So basically, we've got all this information right here, but the only thing that really matters is the 21 to 40 age group. And from that 21 to 40, we're only concerned with how many people are interested in increasing the minimum wage. So that's the 4. So we take those 25 people and put them over the total number of people in that age group, because they just want to know relative to that age group what is the probability. So it's 25 over 50, which is a half. Next one's a little different but fairly the same. You've got a bag containing red, blue, and yellow marbles. Each is numbered either 1 or 2. Table shows the probability of picking each type of ball. So in this case, we aren't given the numbers, we're given the actual probabilities. Okay, and we want to know the probability that you pick a ball that is either blue or with a number 2. Well, in this case, I want a probability of blue, but I also want the probability of having a number 2 on it. We know the total probability of all events is equal to 1. So basically all I need to do is add up all these probabilities. Now note, this 0.3 exists in both. You can't list something twice. So we basically add all these up and we get 0.2 plus 0.3 plus 0.1 all over a total of 1, or a 0.6 probability. That's all we've got for today. Ask your questions. We'll get back tomorrow. Remember, no Connect Ed on these.